All right, hi everybody. Today we're going to be talking about section 2.1a, day 1. Okay, so you got a couple different 2.1, so just pay attention. It's 2.1a, day 1, and we're finding the derivative. All right, so at the end of last chapter, we had this alternative version of the definition of derivative. And remember, it was always the limit as x approaches some x value, and then it was of the slope, so f of x minus f of c all over x minus c. All right, we use this when you are trying to find the slope at a specific point. Your answer is always going to be a number. It's going to be a value. All right, when I want you to use the alternative version, I will say it in the directions, okay? From now on, when you find the derivative for me, I need you to use this limit definition of derivative. It is totally crazy, but again, you are going to use this when I give you it in the directions. So in this homework from 2.1, you're going to do them all like this, and in the future, you're just going to use this when I tell you to, okay? So when you look at it, it looks a lot crazier than what it really is. We actually did this at the beginning of the year without using a limit, and we had the letter H in here. So at the beginning of the year, it looked like this, and an H down here. But now we're in calculus, so we're going to step up our game a little bit, and we have delta x. All right, delta x is just a variable. In your head, you can put a y there, you can put an h there, you can put a w there. It doesn't matter, but delta x is just a variable that we're going to use. Okay, so here, it's the limit is that variable that delta x approaches 0. Delta x is something you're going to keep all of the time. We're going to rewrite this limit all of the time. Okay, and what this formula gets us, whereas this one gets us the slope at a specific point, this one gets us a general definition of the slope. The key is that we find the slope anywhere along the curve. So again, this one is at a specific point. That's why our answer is a specific number, because it's the slope at that number. This one is going to be a general formula that you can use anywhere along the curve. So for instance, we got this curve from a few days ago. We could use this answer that we're going to get to find the slope at this point, 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 because our answer most likely is going to have an x in it. Okay, so we're going to find this general formula, and then we can plug our x value into it to actually get the slope at a specific point. Okay, so this is everything to get started. We're going to do 3 examples, and then that's it for today. Okay, all right, so here's our first one. All right, f of x is equal to 3x plus 2. All right, so I'm going to start out the limit as delta x approaches 0. Now, all this is saying is we're going to take this function, this 3x plus 2. I see an x there. I'm going to take out the x, and I'm going to put in x plus delta x. And then I'm going to finish the rest of the problem. So these and this look very similar. I just took this out, and in its place put x plus delta x. That's all that goes at the beginning of this formula. And then it says subtract off the function itself. Now notice I put it in parentheses because we're going to have to distribute the negative, so I always put it in parentheses here. And then I'm going to divide by delta x. To me, that's the hardest part of just getting it set up, because now that it's set up, now we're just going to apply some algebra to simplify that. Okay, so just like before, again, kind of irritating, but you have to do it. We got to write that limit down again. I'm going to distribute here. All right, we're going to apply the same exact rules as before with limits. If I plug 0 in for delta x, I get 0 down here, so that's a problem. So I'm going to go through and play around with it. Well, once I've distributed things here, things should cancel out if you do it correctly. So this 2 cancels with that 2. This 3x cancels with that 3x. So really what I have left is the limit as delta x approaches 0 of 3 delta x over delta x. Well, now that cancels out. So now I have the limit as delta x approaches 0 of 3. So there's nothing else I can plug into, so my answer is 3. Now I said before on this problem that your answer is most likely going to have an x in it. Here's one of those instances where it doesn't have an x, and here's why. Remember, our answer here is our derivative. That's the slope anywhere along the curve. Well, think about it for a minute. Isn't that just the equation of a line? And isn't that the slope? So isn't it a slope of 3 everywhere around the line? Well, that's what we found. We did all this work just to really say the slope is 3, which we already knew that because it's a line. Okay, so that's kind of our intro one. We're going to do another one with a curve so you can kind of see that difference. All right, slope anywhere along the curve. There's no x in it because the slope is the same everywhere along the curve. All right, stepping up our game here. Here's number 2. All right, 1 minus x squared. All right, I'm starting out. Limit is delta x approaches 0. I'm going to take out this x, and in its place, I'm putting x plus delta x. So it's the same problem. I just took this out, put in that. Okay, now I'm going to subtract off the function itself. All right, if I put in 0, I get 0 in the bottom. So that means I have to play around with it. You're always going to get 0 in the bottom. So we're always going to have to FOIL or distribute. So here, we have to FOIL x plus delta x squared. So that gets me x squared plus 2x delta x plus delta x squared minus 1 plus x squared all over delta x. I'm going to distribute the negative here. All right, if we did it right, some things should cancel out. So it looks like this one and that one, this x squared and this x squared. But I still have this delta x down here. So move over here. I'm going to factor out a delta x in the top. So if I take out a delta x here, I'm going to be left with a negative 2x minus delta x all over delta x. Okay, so now by doing that, that cancels. All right, I still have that. Well, now I could take 0 and plug that in for delta x. If I put 0, that eliminates that term, which means my answer is a negative 2x. Okay, so I plugged it into my formula, FOILed and distributed, things canceled. I could factor out a delta x. That cancels with the delta x on the bottom, leaving me with just this negative 2x minus delta x. Now I can put 0 in for delta x, leaving me with a negative 2x. This is my derivative. Okay, this is the slope anywhere along the curve. Okay, we're going to do more with this tomorrow, but for today, just a matter of, use that formula and get to that answer. All right, we're going to do one more. For those of you that need an extra practice, if you think you're good with 2, then you are good to go and you can start on the homework, and I will see you guys tomorrow. Otherwise, stay tuned and let's do this third one together. All right, so I have the limit as delta x approaches 0. Now I'm going to take out the x here, and I'm going to take out the x there. So I have x plus delta x squared plus 3 times x plus delta x plus 2. Now I have to subtract off the function itself. And that's all over delta x. Okay, again, that gets me 0 down here. So I'm going to play around with it up at the top here. I'm going to FOIL this. I'm going to distribute the 3. And it's plus 2. I'm going to distribute the negative. All right, now I got this limit as delta x approaches 0. If I did it right, a bunch of things should cancel out. So this x squared will cancel with that one. This 3x is going to cancel with that 3x. And this 2 is going to cancel with that 2. So I really have this term, and this term. And if you look at them all, they all have a delta x. So we're going to factor out that delta x, leaving me with 2x plus a delta x plus a 3. Well, now that I've factored out that delta x will cancel down here, leaving me with the limit as delta x approaches 0 of 2x plus delta x plus 3. Now I can take 0 and plug it in for that delta x, eliminating that term, leaving me with an answer of 2x plus 3. All right, that's your derivative. This is your general form for the slope anywhere along the curve. All right, tomorrow we're going to do a little bit more with the same problem, give you some more practice on it, and then we'll move into the next section after that. So we'll have a day in there. I think that Mrs. Cook and I can answer some questions for you guys. Okay, see you later. Hope you're well, and we'll talk to you soon. Bye-bye.